things soon. All right, so yep, today we're gonna be talking about regular expressions. Again, we'll be focusing on Python, so keep that in mind, but regex, again, exists in many other languages. There are also at least one language that I know, probably more, that are exclusively written in regular expressions. So there's a programming language called Perl, which is fascinating. I had a course in it during my university days. Definitely challenging, but definitely interesting also to code completely in regular expressions. But before we get into it, let's actually ask the question, what are regular expressions? So regular expressions are basically a sequence of text characters that specify a pattern that you're trying to match. So again, usually you'll have textual data, you need to match something in it. That's where regex can come into play. I kind of dropped the shorthand name of it already, but usually referred to as regex or regex. I usually go with the regex. I'm not sure if there's, it might be a GIF versus GIF controversy, but I go with regex. Regex is also commonly heard. And then answering the question of why do we need regular expressions? This is to make complex searches in string data easier to accomplish. So again, technically you don't need regular expressions. You could do something manually, but depending on your problem, the manual approach could take a very, very, very long time, and just it's not going to be a good use of your time. Question: how do you actually use regular expressions? I just have a note here: read documentation online. And yeah, that concludes our presentation. Any questions on regular expressions?
Somebody shared like a very helpful tool. I believe it was like when we were going through the pre-course work, like of a website that helped you kind of construct like your testing with regex as well.
Yep.
It's also in the class link that like class reference docs. I tagged it in there because it's really good.
Yep. Yeah. So that's kind of a joke, but I kind of want to again reiterate the point. No matter what we go over today, you're going to be constantly looking up documentation. So that is how you're going to actually get the actual regex that you want for your particular case. Again, anytime I need to like do something that's non-trivial with regular expressions, as Jack mentioned, or sorry, Kyle mentioned, there are online like regex testers, which you throw in a pattern, try to match the strings you're trying to match, and then you tinker it and trying to get exactly the correct regex for it. So again, it's kind of a half joke, but honestly, again, documentation is where you're going to be headed whenever you want to use regular expressions. But we are going to cover a little bit more than just telling you to read documentation. So let's go through a few simple examples of where we do string search and replace maybe, and then talk about where regular expressions actually make sense. So I got a very simple task for you guys here if you guys want to try it. Again, don't expect you guys to kind of code along, but here I just have a text string that says hello to Oscar Platoon. And the task I'm asking for right now is find the location of the first O character in the string. All right, so again, some of you guys might be familiar with string methods. So in Python, the default string class does have a method for finding a particular item. So in this case, if I call text.find, specify the character that I want to find, my expected output should be 4. All right, so I don't know if I want to run all these particular examples, but I have some of it coded up. So sorry, I have a lot of stuff coded up here. Nope, it's not what I wanted. Okay, so first example here, let's just verify so that I'm not spewing lies. All right, so notice we have a text value. We call find on it. We get an index value back. So this is the location of the very first O. So if we verify that, we start at 0 at the H, 1, 2, 3, 4. Yep, 4 is what I would expect here. All right, so that's a very simple example. Hopefully, I haven't lost anyone thus far. Let's go to our next example. Multiple occurrences. So looking at this string, if I want to find all or every location of each O in my string, so there's multiple O's, right? We have the one at index 4, but then we have one at index 5, 6, 7, and then also at 9. I guess, sorry, not at 9. We're only going to look at lowercase O's. So again, there's a few of them in here. So again, using the find method is not going to accomplish our task, because if I go back here, find only finds the first occurrence. So find is not going to do what we need it to do. So task here, find all the O characters. Anyone have an idea how to accomplish this?
would loop through it, or I guess you would use like a for loop.
Yep.
To iterate.
Yep, absolutely. So we do, we can go through each character one by one and kind of check what we're looking for. So I have implemented that. It's going to look a little gross on my slides because I was kind of cramped for space, but I'm using a list comprehension here. So again, good to be familiar with list comprehension. It's kind of more advanced way to write Python, but it's definitely can save you time once you're familiar with it. But basically, I have the same text here. I'm creating a list of indices called index list here. I'm using list comprehension. So again, this looks kind of intimidating to parse, but let's kind of break it down together. So list comprehension, we focus on the for part first. So basically I'm doing a for loop and using my enumerate function that's baked in the Python. So it's going to basically go through each character, which is my C value, and each index of my text string. So again, I is going to be my index, and the C is going to be the value at that index. And then I have an if condition. The if condition is if that character is equal to the O character, then I want it to be added to my list. That's when I'm going to get that I value. If this is false, let's say, C is this capital H, then this is going to be false. And then my list comprehension is not going to return me that I. It's going to go to the next I value. Right? So again, list comprehensions definitely can be intimidating to kind of see, especially on screen and not working with them often, but they are quite handy once you get familiar with them, just like ternary statements. Initially, honestly, when I was coding in C++, I was kind of intimidated by ternary operators or statements just because they were hard for me to visually parse. But now I love them. They save a lot of time. They make your code actually more easier to read. But yeah, so kind of understand list comprehensions. If you're not familiar with them yet, kind of just practice them. When you're writing a for loop, ask yourself, hey, can I write a list comprehension instead? They're usually useful for initializing lists. So kind of getting ahead of myself here, but we have a Sudoku challenge coming up over the weekend. List comprehensions can be useful there. Okay, but enough tangents there. Our expected output in this case should be 4, 7, 19, and 20. So to verify that, again, we have an O here. Looks like I actually missed one. Oh no, sorry, that's index 7. And then we have 2 lowercase O's in Platoon, which is 19 and 20. All right, so we quickly ran that. My coding window, I do have that coded up. So we don't have to type all that stuff in. Yep, doing the same thing here, list comprehension. Going on that, notice we get 4, 7, 19, and 20 is what we expected. Before I move past this point, any questions on list comprehensions? I want to make sure every student understands how to use list comprehensions. And if you don't, please ask me questions so we can break this down.
Yeah, I have a quick question. So how would you add an else statement in there?
Yeah, else statements. So I think you do something like else here.
Capital.
Go ahead, add it here. So let's try adding -1s for those. Yeah, so that's not, there is a way to do it. So in this case, for I char, might need to go to the Googles. There's a way to do it. There's a Stack Overflow question. Okay, so the else goes, I see. So if, okay, so whatever's returned from here, it's going to be none if this if case fails. So in that case, when I do if I else -1. So again, these are kind of hard to read for sure. This is saying if I is valid, that I is coming from here. This I is dependent on this condition. So again, list comprehensions definitely can rack your brain, but basically if this fails, this I value will be none that's returned to this point. So if this is none, this if statement, this if condition will fail. So it'll fall back to the else condition. So if we run this, we don't get -1s here. So yeah, parsing this is a nightmare. Parentheses can always help. So I expect this to be thrown in there. Not sure what's not.
Maybe it has to find no matches for the else to hit.
Okay, might kind of punt on this, apologize. So yeah, list comprehensions can be tough, but you can do a lot of stuff. So A, if B, else, let's try that.
I think it might have to do with the if char equals OO needs to be potentially in your other if
Okay.
statement.
Yes. Yeah, it gets a little dicey here. So I'm going to punt on this. I apologize. But want to focus on regular expressions. So I guess list comprehensions will be another topic. But good question. Definitely more research that can be done on my end and everyone else's end to understand all the possibilities of list comprehension. So I'm going to leave that as is. But yeah, so we accomplished that task. Let's go back to our test list. So we want to find all occurrences of this lowercase o. What if our next challenge is find all the O's regardless of case, right? So in this case, we want the capital O to be returned also. This is very similar to what we're doing before. We just need to factor in the fact that, during our comparison, we want to convert everything to the same case, either uppercase or lowercase. So we do that. Same list comprehension, but the only thing I added here was the lower method on the character, because this will basically standardize everything to lowercase. And so this capital O will be converted to a lowercase here for comparison, but we're not actually modifying, obviously, this character. So in this case, we have the same output, but we get that added 9 here, because that's the index of the capital O. All right, so hopefully you can take my word for that. I'm not going to run that code. And then we're going to jazz this up a little bit more. Task. Find a location of all vowels, regardless of case. So now we're expanding our criteria. So we don't want just the O's. We want the E. We also want the A. Any other vowels, like another A in Platoon. And then again, case doesn't matter either. Any thoughts on how we might accomplish this?
Create a variable of vowels.
Yep, definitely. Yep, so our solution here. I have V. Again, I named these not appropriately because I was limited on space, but V is a list of vowels I have. And then we use a list comprehension and we check in V. So if this character matches any of the characters in here, then we'll want to return it. So in this case, we get more indices returned because we have an E, so it's index 1. This A, I assume, is index 12. But yep, so again, not too complicated. Again, we're able to do this pretty easily, and regexes haven't even reared their head. So the question is, do you ever actually need regexes? Again, need is a strong word, but let's actually look at one more level, or maybe a couple more levels down, a little added task. I'm going to create this concept of a vowel sandwich because we're getting close to lunchtime. So, sandwiches are on my mind. My task for you guys is find all vowel sandwiches in each in each word. And just to clarify what I mean by a vowel sandwich, that means an occurrence where we have in vowel any number of consonants and then another vowel for the same word. So spaces will break apart a sandwich, and that's not a valid sandwich. So in this case, the sandwiches that should be found, this E and this O, are making a sandwich with these L's. So we should return ELLO as a sandwich. This O and this O do not make a sandwich because there's a space here. So there's not going to be a sandwich of O space TO. The spaces are not legit in my concept of vowel sandwiches. It's basically having a sandwich with just an empty layer of nothing. That's not a cool sandwich. I guess that's a cool sandwich, but not going to be fun. So spaces do not count as sandwiches. So in this case, ELLO would be one sandwich from this word. In Oscar, there'll be a sandwich of capital O, S, C, and A. That makes a sandwich. And then Platoon has a sandwich of A, T, and O. The second O does not create a new sandwich because you're not going to have 2 slices of bread. So imagine the vowels as being bread. So this O kind of just doesn't form a new sandwich. It's just going to be A, T, and O for that sandwich. Does that make sense? Everyone clear on what I mean by a vowel sandwich?
Yep.
So I'm going to give you guys an option. So in my head, I had envisioned that I'll give you guys time to work on this challenge. Again, it's not an exhaustive challenge. So I was thinking probably giving you guys 10 to 13 minutes, so maybe till 11:30. If you guys want to take the chance to kind of work on this and solve this task. I think it'd be a fun little algo challenge. Again, it's not a super complicated algo. Just gotta make sure you accomplish, the particulars of finding the sandwich. Or we can kind of forego that and kind of just get through a lecture a little quicker. So I don't know how to do an appropriate poll, but I'm gonna ask 3 random students, and then we'll see what the majority is from those students, if that's fine.
I'm the first random student. We should just go through the lectures and get to lunch.
Okay, that was a unpolled student, but we'll factor that in. Let's see, who I haven't talked to recently. I feel like some of you guys I haven't talked to recently. Vincent, I feel like we haven't chatted in a bit. What would your vote be? Would you rather us just go through lecture a little quicker, or would you guys want to take like 10 minutes to try to solve this challenge without regexes? So again, this is assuming regexes don't exist.
I guess I would think moving through the lecture, I think we all have the challenge and opportunity if we want to work on it over lunch or kind of in our own free time.
Gotcha. I'll ask one more student just to get thoughts here. Scanning through my Zoom. Who I haven't talked to? Thomas. I feel like maybe we haven't chatted in a while. Thomas, any thoughts there?
I concur. I think if we wanted to work on this alone, that'd be best.
Gotcha. Okay, well, so I was actually going to code it up. So regardless, I was going to give you guys the opportunity to code it up, but I was going to code it up also. So, all right, we'll save some time. Definitely appreciate the input. I don't know why I have extra prints. Oh, okay, anyway. All right, so vowel sandwich. I can't code it up here because it's not going to be, I'm not going to be able to fit it here. But the expected output, as we talked about, should be ELLO from the hello, the OSCA, capital O from Oscar, and then ATO from Platoon. That should be my expected output if we all agree on what I'm asking for here. So I'm going to swing over to my coding window and actually have this coded up. So let's kind of look at it. And hopefully you can take my word for it that it is correct because I did verify it. So it is right over here. All right, I'm going to have to actually decrease my font size to fit this all in. But this is my algorithm with some comments, so it's going to take up a little bit more space. But essentially, I'm going to walk you through it, and then hopefully you guys kind of agree with the algorithm. I have my string. I have a list of vowels, and then I have my output, which can be vowel sandwiches. First step that I do is I'm going to split my text, which is like a sentence, into individual words. And I guess I should have specified this. The assumption, so I didn't write this, but the assumption here is that your string is going to only contain characters and spaces. There's not going to be punctuation or any other foreign characters. So that is part of the requirement of this this particular challenge. But yeah, so I'm going to split my string on spaces, which means I'm going to get the words. So it's going to create an array of each word without the spaces, and I'm going to loop over that array to get each word. I'm going to create a local variable called sandwich. That's going to keep track of the sandwich I'm trying to build for each word. All right, so I'm going to loop through each character in the word. So in this case, I'm inspecting hello for my first word. I'm going through each character of hello. So I'm going to start with the H. The H, we're going to dive into the logic here. To start a sandwich, we need to find a vowel. So we need that initial slice of bread. So this H is going to kind of get tossed because it's ingredients that we're not going to use because we don't have a sandwich that we have started. Because we didn't find a vowel initially, that H we just kind of pass over. So this will fail. And we loop again and get to the next character. Next character is an E, which is a slice of bread in our sandwich. So this check on line 39 is going to pass, which means we go into the deeper logic. This check, sandwich size, is going to check, do we have a sandwich that we started ready? Because this is a vowel. So this is either the starting bread or the ending bread. So in this case, we don't have anything in our sandwich size, which is sandwich here. So we're going to add that vowel as in that initial slice of bread. Then we continue on. We find an L, which is the fillings of our sandwich. That gets down here. This else case is that we've opened a sandwich, which is this check that we have something, which is our bread, and we're just going to keep adding consonants, which is the fillings of our sandwich. And then finally, when we get to this O here, we hit our bread case here, where we get another slice of bread. In this case, our sandwich is not empty. We have stuff in it. So it goes down here to this else block or else if block. This is checking that we have some filling. So I guess another special case is if you have bread and bread, that's not a sandwich in my case. You need some fillings in between. So in this case, this is checking that we have at least bread and some filling by having it greater or equal to 2. In that case, where we find another vowel, we're going to close our sandwich with that slice of bread. So we add that to sandwich, append that to vowel sandwiches because we complete our sandwich, and then we reset our sandwich value because we might have theoretically another sandwich within this word. All right, so it's going to loop through all the words, do the same thing. When it completes a sandwich, it appends it to vowel sandwiches. And then once that's complete, we print out vowel sandwiches here. So kind of looking at this, it's definitely not a trivial algorithm or trivial lines of code. It's from line 28 to line 54. So that's about 25 lines of code. If I run this just to verify this works, let's clear this. Did I uncomment that? Yep. Okay. So let's do Python regex, and of course I screwed something up. Did I unindent something? Oh, sorry. That's my fault. Okay, so notice we get hello, OSCA, and Edo, as we expected. So this algorithm, just take my word for it, is correct. I don't think there's any edge case bugs in it, but I haven't tested that thoroughly. But the whole point here is this was not a trivial approach. Actually, I think one of my friends is actually texting me. So do you guys mind if I grab this text? Sorry about that. All right, Regex has entered the chat. Okay, sorry, I'm going to respond quickly. Sorry to waste you guys' time. Yeah, I was just actually thinking about my friend Reggie. I don't know about this. I'm actually not comfortable with regexes. Like I'm not, dealt with them too often, so I don't know if this is a good idea. All right, I mean, regex is making some good points here, so all right, let's just go with it. Sorry for this personal matter that I'm taking care of, but all right, so using regex in Python. First, you got to invite regex over. So you import the RE module. And then once you have RE imported in your file, you can use various methods from that module that can use regexes. So there's a find all. We're going to go through a few basic ones. But yeah, it's pretty simple to kind of incorporate regexes into your application. All right, so this is my regex solution. It's the same algorithm, or accomplishing the same results, but notice it's 4 lines of code instead of 25. So there are some particulars here. So if you've not dealt with regex before, we'll try to answer those questions. We still have our text value, which is hello to Oscar Platoon. We have this pattern. Pattern is just a string. There's this magical R here that might kind of scare you guys. Technically, this would work correctly without this R, but this R stands for raw. It's going to make this a raw string. And we'll talk about that more in detail. In this case, it's optional, but usually when you're forming regex patterns, you want to use raw strings. It just makes it a little easier to develop your regexes. We'll talk about more about this shortly, so stay tuned. But we create a pattern. This is a regular expression pattern. Notice we have our vowels in here. There's some brackets. There's some other fancy characters in here. We're going to go through what all that means. Basically, I create a pattern that's going to match exactly what I'm looking for. In this case, it's a vowel sandwich. I have bread here. I have some amount of filling here. Actually, this is incorrect. So yeah, sorry. This is not quite correct. Yeah, this should be a plus symbol, not a star, for those actually that know regex. But then I have my sandwich here. So basically, it's going to look for a pattern. It's going to search my text. This re.I is basically saying it's case insensitive, so case should not matter. That's just the flag value that the module provides. So in this case, all I'm going to do is search my text. Anytime I find the pattern, it's going to return it in my vowel sandwiches. Then I had to print vowel sandwiches, and lo and behold, I get the same result. So this is highlighting why regexes exist and why you should definitely bother to learn them. Is because would you rather spend your time writing all this code and then having to debug it and make sure validate it works correctly, or take the simpler approach once you understand regexes? Again, it's really this simple. Once you know how to form the pattern will do the hard work for you instead of you having to write the algorithm to do it. Again, we'll go over some of these particulars and how find all works, how regex patterns actually are formed, but any general questions on what we accomplished here? Okay, again, if there's questions, hopefully they'll be answered by the end of the lecture. Let's actually dive deeper into what regexes are. So from the regex module, the RE module, these are common. All right, I need to fix my typos. I apologize. This should be sub, and then where were we before? This should have been a plus. Sorry for typos. Okay, let's get back into it. All right, so these are some methods that you will often use with Python. So there's a search, there's a match, find all, find iter, and sub. So we'll talk about all 5 of these, or at least the first 4. I might have not heard this one. All right, so re.search, basically you pass it 2 parameters. You pass it the pattern you're trying to match, and then the string you're trying to match within. Search will search anywhere in that string. It could be at the very end, it could be in the middle, it could be anywhere. It's going to look for the first occurrence. So this is kind of like that find that we're using on the string earlier. Once it finds an occurrence, it's going to return that one. It's not going to keep searching. Search returns a match object. So this is like a specialized structure that has some important, useful bits of data in it. There's another method, and I'm not a fan of this because I don't understand why they have 2 very similar methods, but there's match. Match, the only difference between match and search is that match only will search at the beginning of the string. So let's say I have the word apple, and I'm looking for the string PL. If I use match and my pattern is PL, it's not going to find it because it's going to look at the very beginning. If the A doesn't match, like that first letter doesn't match, it's going to say, all right, match fails. So again, I don't find myself using this very often. You can use search and implement match with using search. But again, match will only search from the beginning. So there's no difference. There's match and search are very similar sounding. It's easy to confuse. Match will return the first occurrence just like search, and match will also return a match object that defines it at the beginning. That's the key caveat here. Otherwise, none will be returned.
Not to be confused with the switch case that's getting added in the next release that's also called match.
Okay, I did not know that. Good heads up, but yeah, let's pretend we don't even know that somebody else can click with it, just to keep it simple. Then we have find all. So find all is the case where we want to find multiple instances of something. So again, we had a find all case. If I go back, sorry, in my slides. Oops, I don't want to go through all that, but in this case, where we want to find all occurrences of O, that's a find all case. So we could have used regex find all here if we wanted to, but obviously we didn't know about regexes here, so we kind of weren't as fortunate. So where were we here? Yep, to find all, we'll return all occurrences. So we'll keep searching for every copy of that pattern. It'll return actually the list of objects, the matched pattern group. So it doesn't return indices, it returns the actual pattern that was matched inside of your string. Otherwise, it returns an empty list. We have something called find iter. Iter stands for iterator. This checks anywhere in your string, returns all occurrences, just like find all, except find iter returns an iterator to the match objects rather than the actual matches that were found. Another way to kind of just think of that, it returns a list or an empty list when you call find iter. All right, you'll have to convert the iterator to a list if you actually want a list, but otherwise, like an iterator gives you the ability to iterate through the object and do what you want with match objects. Then we have re.sub. This one's really useful for your challenges today. You'll probably be using this. You don't have to. You probably could get away without it, but it's going to be much harder. So sub lets you substitute a found pattern with some replacement substring that you specify. So you search for the specified regex pattern anywhere in the string. So you supply a string. So the string could be hello to Oscar Platoon. The pattern, if you want to replace, like, let's say you want to replace Oscar with Papa, which is going to be a platoon coming after you guys. My pattern would be Oscar in that case, where a replacement substring would be Papa, and then my string would be hello to Oscar Platoon. When I call re.sub, once it finds that pattern of Oscar, it's going to replace that entire match, whatever matched that pattern, with what I specify, which would be Papa in this case. In this case, we return a new string, because again, strings are immutable objects. If you're going back to a lecture from week 1, strings can't be updated once they're created. You had to return a new string. So read.sub is not going to modify string. It's going to return you a new string with the replacement substring in there. Again, this will replace all occurrences of patterns. So let's say I had Oscar the Grouch is our logo for Oscar Platoon. In that case, Oscar will be replaced in both cases. So sub will search everywhere and do it for all occurrences. Questions about these methods? Again, it's probably good to see an example, but you guys will be experienced with it. So this is where I'm going to say, better for worse. Read the documentation and get a better understanding of it. There is definitely great resources. So if you just go to docs.python.org, this is the page I use most for using regex in Python. It's a very long page, a lot of content on it, but it talks about match objects. So if you want to know more about match objects, they have methods to get specific data out of match objects. Yeah, a whole wealth of information on here. Obviously, I'm not going to go through this whole page, but you guys definitely will be referencing this for your challenges, I assume. All right, so those 5 methods, again, are going to be pretty common. There are other methods, obviously, that the module provides, but pretty sure search, find all, and sub are going to be your top 3. Find iter you probably won't be using, and then match I avoid using just because it's kind of redundant for search. We talked about the match object, just kind of highlight it. The match object that's returned, again, a lot of these return match objects, like match, search returns match object, find iter returns a list of match objects. Match objects contains, again, a lot of useful information. They'll contain the start and end index of the entire group that's matched. So again, you might not be just looking for one character, you might be looking for an entire word. So I'll point you to the start of that word and the end of the word where the pattern was matched. It also tells you the original pattern that you're targeting, the pattern that was found. So in addition to the indices of where the pattern can be found, it'll actually tell you which pattern was matched. And also it contains like the original pattern and the string that was passed in. So it just gives you, again, access to useful information for whatever you might be trying to do. You guys with me so far?
Yes, sir.
Yep.
All right.
How do you reference those?
How do you reference? Good question. So there's going to be more documentation, but I think I have that up here. So there's a span function. So there's start and end. So this will, you pass it the group. So you might have multiple matches. So the group number is which number you want to match. So here, like if you pass it the value of group 1, it'll give you the start and end for that group. And also span will give you just the ending and starting points. The match, so these are original values, the regex and string. There's a way to get the match. So if you call group, I believe, I did run through this, but if you call group and then group number, it'll give you the actual match string. So again, a lot of this might be confusing. Documentation has way better examples than I'm going to be able to provide. All right, kind of proceeding on. Let's actually talk about regex patterns, because this is the core of regex. All the stuff I talked about earlier, they use regex patterns. But how do we actually form regular expression patterns? This is where, again, more practice, the better you get at it. But even then, I've done this, I've used regexes a fair amount, not extensively, but I'm always going back to documentation. In fact, I actually have a cheat sheet. You're going to want to find one of these and bookmark it because you're going to be looking up a ton. But this specifies all the regular expression meta characters you might deal with. All right, so there's no way I have this memorized. Maybe if I use it every day, I might have it memorized. But again, I look this up constantly whenever I need to use regexes. Well, let's go over the basic ones. So the most common ones you're going to be seeing, square brackets. This defines a character class. All right, curly or round parentheses, that defines a group or a captured group. And we're going to be talking about these with examples shortly, so stick with me. But just know square brackets equals character class, parentheses equals group or capture group. Then we have specific characters. This might be kind of hard to see, but there's the period character. This basically matches anything. If you have a pattern that has a period in it, that's going to match anything that it finds. It's a wildcard character. The only exception to this is that it will not match a new line character. So periods will not match new line, but will match anything else. It'll match spaces, any numbers, any single number, or any alphabet character, any white space characters like tabs or whatever, a period will match that. Then we have this caret character. This is kind of tricky. On its own, it matches the start of a line character. So basically the start of a sentence. If you want to like start your search from there, you'll specify this character, this caret character. Likewise, there's this $. That's a special meta character which matches the end of line characters. So end of line characters can be new line. There's /n. There's also a /r, which is carriage return. That also creates a new line. Again, there's more than one new line character for end of line. This will match any of those. Again, these are matching single characters. But then we go over to the next column, and these are matching multiple instances of particular characters. So we have the asterisk or the star character. This specifies you want to match 0 or more times. So it might exist or might exist 20 times or might exist 0 times. Star just means anywhere from 0 to infinity times, match it. Question mark, similarly, matches 0, but only 0 or 1 time. So question mark just means, hey, are you there or are you not there? Either way, match, but it's not going to match multiple characters. It's going to match either 0 times if it's not there or 1 time if the character is there. Then we have the plus symbol. This meta character matches 1 or more times. So this is specifying that the character must exist, but it can exist as many times as it wants. Again, this is different than the star character, which says, hey, you don't have to exist for me to match what I'm trying to match, but you can exist or exist multiple times. Okay, so these three, again, they're used in conjunction with character classes or some of these meta characters. Finally, we have the curly braces. This lets you specify how many times exactly you want to match. So you could specify like, hey, I want to match this particular character exactly 5 times. You pass it an X value and leave off of that Y value. You might want to say, I want to find this particular character 5 up to 10 times. That's when you specify an X value and a Y value. So you pass 5 and 10, and that'd be combined with one of the other characters. Okay, so throwing a lot of information your guys' way. Again, I know this is probably very confusing, especially if you've never dealt with regex before. Let's get a little more detail, and then we'll dive into some examples that hopefully will make more sense. We have predefined character classes. So the common ones, if you use /d in your pattern, that's just going to mean it's going to match any numeric character. So a digit of 1, 2, 3, all the way up to 9. A single /d will match 1 numeric character. The opposite of that is /D will match any non-numeric character. All right, so these are predefined character classes that exist in Python regex. We also have /w, which will match any alphabet character. And likewise, /W will match any non-alphabet character. And then we also have /s, and great, another typo, my apologies, that should be S. So lowercase s will match any white space character. So again, white space characters can be spaces, tabs. I'm not sure if there's others, but S will match non-white space characters. So again, these are the predefined character classes. You can combine them, create your own. So in this case, if I have square brackets, that's creating a character class for myself. In this case, I combined digits with words or letters. So in this case, this character class will match any alphanumeric character. So that would match, 1, 2, 3, 4, 5, 6. It'll match A, B, also capital A, capital B. Anything that's alphanumeric will be matched by this. As I sort of mentioned before, we have this caret character that popped in before that we talked about earlier. Here, we talked about it as the start of line character. This caret and the usage of this character are totally independent. So that's why it can be kind of confusing. When you use a caret within square brackets, that's basically a negation symbol. So I don't know why they couldn't have used a different symbol. I didn't create the syntax for regex, but used inside of square brackets, characters mean not. So in this case, it's going to say, don't match any alphanumeric character with this character class. All right. What questions do you guys have? All right, let's look at a few examples on screen, and then we'll actually do some by ourselves. So here's a few examples, just to go over them. So in this case, where I have a character class of A, B, and C, and then I have a Z after it. The Z is a standalone Z. It's actually going to physically match a Z because I'm specifying whatever I'm trying to search for should have a Z in this position. Notice I don't have a caret for this particular example. So this is going to say, find it anywhere in my string. You don't have to find it at the very beginning. So in this case, we'll match AZ, BZ, CZ, as well as Jazz. Jazz will match because if we think about it, anything can come before here and it'll ignore it because this match can be a submatch. It doesn't have to match the entire string. So if I want to give this a better example, let's actually code something up. So let's get rid of our gigantic algorithm here. Sorry, I'm in trouble with key presses here. Shift and yeah, let's go to another file here. I can use on that. All right, so import re. Again, RE is regular expressions module. Let's create a character class. So I'm going to say pattern equals raw string, and let's call we had what was it, A, B, C, and Z. All right, so this is our pattern. We're going to use one of those regex methods we talked about before. So let's do re dot search, and let's look for that pattern inside of our strings. We need a string, obviously. So let's give text equals Jazz. And this is going to return a match object. So let's call it match. And then we could print out match if you want.
Wouldn't you type in text and not Jazz there?
Yep. Okay, so again, the regex regular expression module has a search method. That method will take in a pattern and text, and they'll basically search anywhere in that text object to find this particular pattern. So let's actually break this down. Well, let's actually run it first and then talk about it. So Python regex, I want to call Python hello. All right, so we have this match object. Again, there's no str method, it looks like, so we don't get a nice output, but basically this is giving us a span. So this is saying it found a match of AZ. So match this portion. This pattern, match this portion right here. All right, the reason that match is because this character class says, give me A, B, or C, and then pair that with a Z. So anything that's AB, AZ, BZ, or CZ will match this. So since this has an A and a Z next to each other, this matched. If there were a letter here, let's say I threw in an X here, this will no longer match because this pattern is not allowing for some random character to be in between here. So if I ran this, notice I got none as my return value. If I did want to match this, again, this is diving back to our character class that we talked, or meta characters we talked about. Let me ask someone in the audience. Hopefully, I'm not going to catch anyone off guard. I see James on my screen. James, if you were to kind of guess or know, if I wanted to match A, X, and Z here using something similar here, how would I have to update my pattern to match A, X, and Z?
To match A, X, and Z.
Let's say I want to match A, X, and Z, or A, X, and W, whatever. I want to have anything here, but I want to match these three characters. So basically my requirements are I need an A and a Z and anything in between here.
I'm not sure.
Fair enough. Yep. Again, regex is definitely a new concept here. So in this case, if I want to specifically match A and Z and anything in between, I would change my regex to be simply A period Z. So what this is saying is A has to be matched. Period means it's a wild card, right? So again, that's something that we're just going to get familiar with as we use regex more. Period means match anything. So in this case, that anything can be, it can be an X, it can even be a space. So if I had text equals JA space Z, Z, this will also match because anything includes a space. Let's say I did not want to match this. How could I change this so I only match these two, find a match in these two, but not this one? Anyone have an idea?
One of the things was for like all letters, right?
Yep. Those character classes again. That's where their cheat sheet comes in play. So if I look at my cheat sheet, I don't know if it's too hard to see, but yep, there's regular expression character classes. So we have, we do one word character if we want to do that, or maybe we want to just ignore white space. So if we had a number in there that could match, again, it depends what we're trying to match here. So I'm actually going to do the capital S, which means ignore space, but it will fly for if I have a number in there. Let's use 8. All right, so in this case, if I code this correctly, I'm going to use a \S. In this case, I'm going to say find an A, find anything that is not a space character, and then a Z immediately after. So if I run this for my 3 examples, let's name these a little better: text 1, text 2, text 3. Let's run it for text 1. Let's just run it for all of them. So we have text 1, text 2, text 3. Let's move these and make it a little easier to understand what we're running it on. All right, so pattern is the main important part here. Otherwise, we just have some candidates. So our candidates are jazz with a space, jazz with an 8 wedged in there, and then jazz with an X embedded there. All right, so if I run all 3 of these, I would expect that this should fail, as in return none. The next 2 should match because this 8 is not a space character, so that's good. This X is not a space character because this meta class is specifying we don't want to match the space. Anything that's not a space is good for us. So if I run that, we get none. But then look, our match objects did match A, 8, and Z, and then also A, X, and Z from our 2 candidates. Again, when we had it before, we had A, B, and C. If we have something like this, this will allow us to match. This can be a B or this can be a C. Will also match. This is saying take any character from here. All right, so these character classes are just a short form for basically creating your own. So we talked about /W, right? /W here. That's the same thing as if I manually wanted to create A, B, C, D, E, F, and write out the alphabet, and then also write capital A, B, C, and so forth, right? So it just saves me, time from having to create that myself. So /W takes care of creating that character class for me. Same thing with digits, right? I could write a character class that has, 1, 2, 3, 4, 5, all the way up to 9. I guess a 0 in there also, but /D will take care of that for me. All right, let's go back to these examples. So all right, so here, same case here, but we have this caret. Again, this caret just means match at the beginning. So in this case, jazz would not work. Maybe I want to specify that here. Jazz is what I want. All right, so in this case, jazz will not match. The reason being is because this is saying you must start at the line, have an A, B, or C immediately after the start of the line, and then a Z. So in this case, the J and the A, the J will break this pattern. Because there's a start of line, which is an imaginary start of line here. Then it's checking, hey, do we have an A, B, or C immediately after that start of line character? We get a J, so the pattern fails. All right, so if I make that change in my code, let's change this to, I'm gonna put the A back, just make it a little simpler. So now that I have this A with the caret at the beginning, this is no longer going to match any of these J's. All right, so if I ran this, I should expect 3 failures. Ran that down here. All right, so I got none, 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 none. Sorry, only 3 nones because this J breaks it. But if I take away that J, let's take away from this one because I only am matching A. Now at the start of the line, my start of line character is matched, which is an imaginary character here. Then this A is matched, and then I get a non-space character, which is X, and then a Z. So in this case, I would expect the last one to pass. Yep, I got a match object that matched A, X, and Z. Okay, so that start of line character can kind of change what you're looking for. Let's go through a couple more examples on screen and then wrap up with a few more dynamic examples. But here, you can create a character class.
I got a quick question, Ankur. I'm sorry.
No, you're good. Apologies necessary.
You had the A, the example has the A inside a bracket, but in the code you run, it didn't have a bracket. Does that, I guess that doesn't matter then if it's just one letter?
Yep, you got it correct. So glad you asked that because I definitely kind of glazed over that. So Eric's question comment was correct. Here, I just have a single A that's not in a bracket. If I put it in a bracket, it's going to do the same exact thing. The only reason you need brackets is if you want like an option. So in this case, if I want to do A and B, I need the bracket to say either A or B. If I leave the brackets off, like if I make it like this, now my pattern is going to say, okay, I need to find an A and then I have to find a B. It's going to try to look for both in that order. So the brackets just say you need one of these, not all of them. But yeah, great question. I'm glad you asked it because I definitely kind of missed that point. But yeah, so if you have one character, brackets are optional in that case. If you want to combine stuff, like if I create something like this is going to say find an A, find a Z, or find anything that's not a space. So effectively, it's going to match anything that's not a space because A and Z are encompassed in this class. Oops, oh wait. Okay, so you could also create ranges. So here I have A-Y. That's not actually like a minus operation. It's just creating a range. This is actually going to create a character class from A, B, C, all the way down to Y. Okay, so in this case, it will match anything that's AZ, BZ, CZ, DZ, EZ, all the way down to YZ, because that's where I'm stopping. All right. So again, you create a range. It saves you writing all those letters out. Another example, I'm using that character class of digit. So in this case, I have a digit. The brackets are optional here. So in this case, we'll match 1Z, 2Z, 9Z, but not 88Z. The reason being is because this is a single character of digit. But to open that, I guess, case out more, so I have /D and a Z here. That will match 8Z because I have started line character. Question for anyone that wants to try to answer. Let's say I want to match 88Z and I also want to match 770, let's say 776 in Z. With the one pattern, I want to match all three of these. How can I accomplish that?
You just have to drop that caret.
Yes, sorry, yeah, that would work. Yes, so Jack, you are correct. Not what I was going for, but that was my mistake. So let's say I add.
Sorry.
No apologies. You caught me there. I was right. Let's add Z's here. Or I don't want to throw you guys off. Let's just add a Q. All right. Now, how can I change my pattern to match all three of these? There's more than one right answer, but there's usually a best answer with regexes.
Would you put the Q in front of the bracket?
Yep. Yes. So you got me again. Yes, a Q here would do it. But let's say I only want to match this part. I don't care about this character. So sorry, a Q will not fix it actually.
Drop the caret at the beginning and add a plus after your right bracket.
Yep. You guys are coming up with great solutions. I guess I am failing at trying to give the example I want. So basically,
Guess you're thinking of the dollar sign.
Not quite, but yeah, there's another meta character I want to use here. So basically, my pattern doesn't want to even match this. So the reason your suggestions aren't meeting up with what I'm trying to do in my mind. So you guys had valid suggestions. So one suggestion was drop that, and that will match that. But this won't match the 88C. So I guess, yeah, that case won't work. So if I run this, notice I want to match 88C. I don't want to just match 8C.
Right, that's why I said put a plus after the slant D close bracket.
Gotcha. Yep, so we're on the right track here. So I run this. Yep, that works. So plus means one or more. So basically it's saying you had to find at least one digit, in this case 8 or 88, but then it says find as many more digits as you want. So, and it's going to capture all of those. So in this case, it finds a 7 and then it continued on, captures all those. Because the plus means one or more, as many digits as you want in this case, but you have to have at least one. So in this case, if I had RZ here, this string would not match anything because there's not at least one digit present there. You guys kind of getting the hang of it. Again, you guys are going to go through tutorial after tutorial to kind of master this, but what did I screw up here? All right, so you'll see this often, dot star. Dot means anything, star means as many times as you want. So that's actually gonna capture all of these characters. So if I want to ignore them, one way to do that would be creating a group. So I do that. That's not what I wanted. Yeah, I guess I'd get rid of the starting character if I want to ignore anything before this. But yeah, my main thing was here. Yeah, you want to do a plus with the digit meta character or class character. One more example, and then we'll kind of wrap this up. So again, you could do not D. So that, again, this caret outside means start of line, inside means not. So this will match AZ, BZ, and C because we have a question mark. Again, question mark was another meta character. This means that the Z is optional. It can exist or not exist. It'll match it in either case. So in this case, AZ, BZ, and C without the Z will match because the A is not a digit and the C is being captured here because it's a non-digit character. The Z can be there or not be there. One Z would not match because that's a digit plus a Z. The Z would match though. So again, but the one Z would not be the match character. The Z would match if I had a string of one Z. The Z would match from here, or I guess here. 2 would not match because 2 does not satisfy either of these. It's not gonna match this pattern, and Z is not present here, so that won't match. All right, let's kind of expand on that a little bit more. So I had not D, and then I had Z question mark. What if I had a question mark there? What sort of strings would I start matching there? So in that case, this is optional, and that's optional. So I can match empty string. I think that should match. I should be able to match. I think anything would match. Basically, anything that's not a digit. So 1 would not match. Sorry. This is saying anything that's not a digit, and this is saying a Z or not. So in this case, 1 would not match because that's not going to pass either of these. So if I ran this. The empty string, why is that? Oh, because, sorry, I lied. This pattern says nothing can exist and it still matches it because both of these are optional. So in this case, this 1 doesn't fail because it matches nothing out of here. Is this making sense or am I just talking in circles? I'm losing you guys. Can't tell.
I get it.
All right, again, no worries if you don't get it. This is a totally new language. Again, the syntax is really weird. Again, cheat sheet. Kind of look up Python Regex cheat sheets. There's a bunch out there. Just kind of understand the key takeaway should be understand what these kind of can accomplish, and then you can combine them into various combinations to achieve what you want. So that kind of gets to my key takeaways. Just know what regular expressions are. Know the basic Regex meta characters. So again, the period, just know that's a wildcard. If you see a star, this means any number of times, 0 or more times. Plus means 1 or more times. Question mark means 0 or 1 exactly. You could also specify with curly braces. I see we're hitting the noon hour, so let's quickly go through our challenges for today. Where are we? Okay, so a whole bunch of external resources. Again, I wasn't lying when I said just go look at documentation. So that's half the battle. I think Jack, repped some of them. I think Regex 101 is a great one. Load. So here, again, there's a lot of Regex testers here. So let's try something we're doing before. So my regular expression, let's do not/d and what I have Z question mark. Then you could have a bunch of strings here and try them out. So if I do RRR 5Z, so I get multiple matches here. It matches the R because that's a non-digit character, matches the second R, third R. So it kind of gives you more information of what it's matching. So in this case, I get 4 matches from this one regular expression search. So it's doing like a find all. Again, the reason I match all those is because I made non-digits. The 4, notice the 4 is not matched here because that's part of my requirement. It's not a digit, it's part of the pattern. If I put a question mark here, then anything will match basically because either part's optional. So here, I guess I got an empty string because nothing was matched here. This is now effectively an empty string. But yeah, it's a lot of resources that we have linked. You guys can find your own also. Definitely go through some of these. Regex 101, Pythex, just a lot of great resources out there. I think Regex 1, let's kind of look at that. They have challenges And I think it's really helpful for learning them. So don't just say, hey, it's a tutorial, I'm going to skip it. So they give you exercises. So in this case, they're asking you to match A, B, C, D, E, F, G, A, B, C, D, E, F, and A, B, C. Anyone want to take a stab at this? All right, I'll lead us off. So each of these strings have A, B, C, and notice as I type, it kind of highlights what I'm matching. Let's say I put in the wrong character. Now it's not matching any of them because this X is not found in any of them. I put a question mark here. This still matches it because now this is saying this X is optional. But we want to match the entire string. So in this case, ABC is required. And then I could have something like /W, which means any word character, put a star next to it. So this means definitely find ABC and then find any remaining text as you want, 0 or more. So this case has 0 extra characters. The other two have extra characters, but it doesn't care about the count. It just says take as many as you find. This is known as a greedy operator. It's going to take as many characters as it matches. Let's do one more. Match digits. Okay, so we only want to match the digits in this string. So again, you're going to write a pattern like /D. Okay, it matches one digit. We want to match as many as we can. So put a star. That doesn't accomplish what I want. So let's think about this. Digit as many digits as you want. So this is saying 0 or more, but we actually want at least one digit. So in this case, we need a plus. So that matches at least 1, and it counts up as many as it wants. All right, so when we get all 3 check marks, we're good. Again, these get harder. In this case, we want to match some, but not all the strings. So again, you want to avoid particular items. So in this case, ABC1 should be ignored, but CAT should be matched. So that's telling me that A, B, C in that particular order should be ignored. So I could do something like not A, not B, not C.
Did you put that in a bracket or no?
Yeah, so put it square brackets. Maybe this is a good chance to use this operator. I'm gonna have to think about this a little bit. So we haven't talked about this as an example, but this means match exactly 3. So this is matching these 3, it looks like. So
Ankur, I have a question.
Yep.
No, you were going that direction anyway.
Yeah, sorry, this should be inside because that means not. It's basically it's gonna match 3 characters that aren't A, B, and C, but that's actually not quite solving this because I'm gonna have to think about this. So again, it can be a challenge. I find it to be a fun puzzle. I will say this and doing CSS can be really frustrating, but really enjoyable at the same time. I really like solving puzzles, and I find, writing these regexes, again, trying to match particular items. It's a fun little puzzle, can be frustrating, can take you like 15 minutes to do like one of these small challenges. So it can be kind of frustrating in that sense, but also gratifying once you kind of get the hang of it and can blow through these a little quicker. Okay, so Regex 1, definitely do some of these. I don't know how deep it goes, but it looks like there's a bunch of challenges. So it goes over all the types we talked about, like using character classes, using those count operations, repetitions, uses a star, plus, question mark. So it goes through basically all the basic meta characters that we kind of touched upon. Okay, we have app user 3. There's not too much to talk about here. You guys have done 1 and 2, so it's just kind of expanding on that. Basically asking you to do a few items. In this case, we're going to be using inheritance. So we're creating premium user and free user off of our base user to kind of get you comfortable with using inheritance. Finally, phone numbers. This is a fun challenge. I'm going to recommend it for all of you guys. This employs regex. So give you great practice in using regex. Basically, we have the test written for you. Your goal is to implement the functions that converts basically when you call phone number with legitimate phone number, you get true. You might have a format phone number. So for example, phone numbers can be written in various formats. So if I look at the last challenge, you could have parentheses in your area code right here, right? Let me blow that up a little bit. So you have 312 in parentheses, and then your digits and a period sometimes. That's a little rare format. You might just have all your digits together. You might have periods between your blocks of digits. You might have dashes. All these are valid phone numbers. We want you to be able to take those and format them in a standardized way. So again, this might be common practice when users are inputting various phone number formats in a form. You might not be able to tell them, hey, always use dashes. They might not follow that. So regardless of whatever format they put, you might want to standardize it in your database. So regex should be your tool to use there, so that you could take any I guess close input, that what you're looking for, and then format it to what you're looking for. All right, that's a lot of talking for the last 3 hours. What is on your minds before we break for lunch? Again, regex, don't sweat it. Just try your best. If you never want to look at regex again after today, you're gonna be fine for the curriculum. We don't mandate it. We don't use it extensively. It's just a tool in your toolkit. Again, a lot of tools we talk about, like recursion, that should be in your toolkit. When we talk about, just test-driven development, that's another tool in your toolkit. Using try except, just all these tools should be in your mind, that when you reach a situation, you might, did that smell test? We're like, that smells like I should use regex. Again, you might just kind of notice, like, instead of writing a complicated algorithm, regex might make it much more simpler. So kind of just keep an eye out for that, and then deal with regex when it comes that way. All right, that concludes everything I had to say for the last 3 hours. Any questions before we break for the afternoon?
What order should we prioritize our assignments? Should we look at external, or dive straight into the assignments?
I'm gonna highly say read the external resources, especially if you've never seen regex before. Again, we have a lot of them, so maybe don't worry about going through all 8 of them. Definitely go through great tutorial, Pythex and Regex 101. I've used Pythex. That's just an online tool for, again, testing out your solutions. You're probably going to be using these tools with phone numbers, because again, phone numbers is not a give me challenge. It's going to kind of press you, especially as a new topic, being regex. But again, if you kind of struggle with these, and let's say you're spending like 3 hours on them and you're like, I'm still not getting it, I'd say just kind of, tap out and focus on OOP, because that is what your assessment's on. Regex is not going to, show up in the assessment. It's more of a one-off topic that's, again, good to know about, nice to have, but not a must-have in this case. Okay, definitely do Regex 1. This, I've used it. It helped me learn, kind of get better with Regex. So just going through, again, those challenges that I had it before. Again, it goes through all these challenges. So if I go to this, how do I match was up, but not just was up with 1Z? Maybe you know off the top of your head, maybe you're gonna have to mess around with it, but great practice here. So definitely do this. I'll just say that much. All right, with that, I appreciate you guys' patience. Sorry for running into lecture time, or sorry, into lunchtime a little bit, but with that, that's your intro to regexes.